This is your host Swapnil Bhartiya and welcome to TFiR Let's Talk. And today we have with us Michael Gielda, VP of Business Development at Antmicro and also Chair of the Zephyr Project Marketing Committee. Michael, it's great to have you on the show.
Hi, very nice to be here.
And Michael, can you tell us quickly, what is the company all about?
Sure. The company is a service company building open source technologies for customers. So we use open source to create products, tools, and basically things that help our customers move faster when they're creating physical devices.
And what kind of customer or what kind of device are we talking about here?
It's all sorts of edge AI stuff. It could be robots, drones, agricultural devices, space satellites, cars. So anything that has some kind of intelligence embedded inside, especially if it's advanced intelligence. We specialize in Linux and Zephyr and building, AI solutions on top of those operating systems. But generally speaking, it's all kinds of open source. And since recently, it's also, building the underlying technologies. It's also building the technologies for creating chips or developing FPGA IP. So it's really broad, and we focus on the technologies themselves. We don't focus on a specific branch of industry.
What role is Zephyr playing in your technology stack or the services solutions that you offer to a wide range of solutions there?
Zephyr is one of the key technologies because Zephyr likes to say about itself that it fits anywhere that Linux doesn't. And since Linux is kind of also a key technology for us, we cover a lot of the higher end devices with that operating system. Naturally, everything that cannot run Linux or for some reason requires some kind of real-time operating system will be running Zephyr most of the time if we're to decide, right? It doesn't mean we only work with Zephyr. We work with a lot of different kinds of operating systems, but certainly Zephyr is the go-to operating system for us. And the reason for that is its vendor neutrality. It's kind of Linux-like development methodology. Its structure. There's many aspects of Zephyr that kind of fit very well into how we see systems as portable, reusable, modular, much like Renode, the open source simulation framework that we're developing. A lot of the thoughts that go into structuring how Zephyr is and how it's built are shared between other technologies that we build and use. So Zephyr is kind of a natural choice for wherever Linux isn't a good fit.
Can you also talk about, as you said, Zephyr itself supports a lot of boards. Is there any specific, kind of boards you support, or you can simulate any board? Doesn't matter because you have to actually, as you said, you can also help with debugging and all of things. So it's just not simulating the board, but you have to go deeper into that. So can you talk about that aspect?
Absolutely. There's a lot of coverage that we have, but of course there's a lot of things that we haven't done yet. I'll talk about the things that we've done and perhaps hint at a few things that we're planning for. In general, the ecosystem that Zephyr covers is mostly, ARM on the one hand, Cortex-M devices is one of the primary focuses, I would say. But there are also different architectures. There's RISC-V, of course. There's Extensa, there's ARC. There's a number of different architectures. ARM is, of course, dominant. It's one of the biggest contenders in the IoT space, which Zephyr also covers. But it's by no means the only one. And so Renode similarly covers a broad range of architectures and focuses mainly on ARM for the small IoT devices. But we also have, for example, very, very strong RISC-V support. And actually, just recently, we added support for the Extensa architecture, which will allow us to also support, for example, the expressive platforms that have pretty good representation among all sorts of hobbyist and maker projects in the world. So generally speaking, there's a broad range of things that both Zephyr and Renode support. And of course, when you talk about Zephyr and Renode support, you should also talk not just about platforms, but also interfaces on those platforms. So there's both wired communication interfaces, wireless communication interfaces, and we do both. And now naturally, our coverage is, kind of better here and worse there. And we're kind of improving that all the time with vendors. It's been a great collaboration, since we became a platinum member of Zephyr Project. We've worked more closely with the hardware vendors, and we've been able to, just directly interact with them to improve support for their own platforms in Renode. And we have things like Bluetooth support as an example for Nordic platforms, but just literally today I learned that someone's going to contribute some Wi-Fi support on Silicon Labs platforms. And in general, we've done lots of different interfaces like CAN, like Ethernet, like, of course, SPI, I2C, and so on and so on. So there's plenty of topics there. There's plenty of complexity. And this is by no means to say that we've done everything there is to do. On the contrary, there's still quite a long way ahead of us. Just like with Zephyr, right? There's always new platforms being released. There's always new and more interesting peripherals to build drivers for. But that's what we offered. As a company, we kind of build those tools as a service. So it's kind of great to see this technological development that we can kind of follow, and perhaps not even just follow, but spearhead, right? And help push this in different kinds of directions. One of which is making it more open. One of the things that we have been focusing in Zephyr is trying to explain how important it is to keep Zephyr open and vendor neutral and standardized. We believe this is, the only way to address this complexity really is openness.
What are the things that you see are in the pipeline, or the things that Zephyr community should and is working on?
There's one big area, of course, RISC-V, where it's an up-and-coming ISA. I mean, it's not so new anymore, but it's still kind of waiting to be deployed wider and wider and wider. And of course, our fingers are crossed because we believe, an open source ISA is the right way to go. So we're kind of supporting quite a lot of RISC-V platforms in Renode, but also in Zephyr, we're kind of helping maintain that particular ISA. And it's a challenge in the sense that, we need to make sure the hardware is there. We need to make sure that the abstractions to cover all the profiles that RISC-V has and some of the complexity that's built into the modular nature of RISC-V is addressed. Because with ARM, for example, you could just rely on the fact that by the time Zephyr came around or became popular, ARM was already so widespread that it was kind of obvious, what to target. With RISC-V, it's kind of we're still pushing to get more platforms, more boards, and it's still kind of developing as an structured set architecture and as an ecosystem. So making sure that these two things work together well, I think is a great challenge. It's one of the challenges that I actually like because it's pushing, two neighboring worlds forward together.
Earlier, you also talked about FPGAs and RISC-V architecture. Can you talk about how is Antmicro kind of leading the use of Zephyr in FPGAs and RISC-V architecture and for both hardware and software implementations?
Sure. So FPGAs is a great area where hardware meets software. It's kind of hardware that you can develop with a software methodology because you can change it all the time. Changing your FPGA bit stream is just, can be a matter of seconds or at least, minutes, hours, but not days, weeks, and months as it is in regular hardware. So FPGAs are kind of neat because you can think of them kind of as software. It takes a little bit of skill to actually program FPGAs, but we do that, and we actually try to approach it from a very software perspective. And what many people do not know is that modern FPGAs can actually run pretty decent soft cores in them. We've been able to run Linux-capable multi-core SoCs inside FPGAs, like small FPGAs that you can buy for reasonable money. And people don't typically believe that when we tell them, when we show them, look, you can actually run Linux on top of this. They're like, oh, I just didn't realize that FPGAs have gotten so good. So Linux on FPGA and Zephyr on FPGA, these have been relatively unknown topics before, but because people tended to think of FPGAs as something that's just like only for parallel processing, you can't actually build a decent CPU inside of them. But now, like any FPGA on the market, mostly can run a Zephyr-capable CPU. So what we do is, typically when we build anything with FPGAs in it, we put a soft core inside that FPGA, and if we do that, we're actually going to put Zephyr on top of that FPGA because we have very good support for a lot of RISC-V implementations, including for the VEX RISC-V, which is one of the key FPGA-oriented cores that we use, and that's kind of our work, right? So generally speaking, Zephyr on FPGA, we have some tools for programming FPGAs from within Zephyr and so on and so on. It's been definitely a major focus. And of course, like it's a natural pathway from FPGA to RISC-V ASICs. So these topics are kind of inherently related.
And one of the many open source technology that you folks, leverage and use or contribute to is also Renode. Can you talk about, how kind of Renode helps build, Zephyr-based product, and what specific problem are you trying to solve there with Renode and Zephyr?
Yeah, Renode is a simulator. So it's a tool for faster and more effective development, especially if you're trying to test your systems. You really need simulation tools because that allows you to cover lots of scenarios and build systems that are completely reusable, and you can share them with colleagues, develop across teams, across continents, basically. So a simulator like this is very useful for developing real systems. And of course, if you're using a real-time operating system, you're trying to build some drivers, you're trying to create an application, a lot of the time you'll run into problems that are not so easy to debug in software, in hardware. So a simulator really helps in that regard. And Renode targets specific devices. It doesn't target like only architectures like ARM or RISC-V, but it targets real boards, right? We simulate real boards with peripherals, so we can test end-to-end applications. And that is a very important aspect because as Zephyr markets itself as an operating system with an ecosystem and with all the tools and modules and applications that you require to build real products and not just prototypes. So is Renode kind of a simulator that allows you to build real products and not prototypes. So we can do multi-node system simulation, for example, for testing protocols and communication between different nodes of a system. Or we can, create heterogeneous systems with multiple CPUs. Very often Zephyr is used on some kind of auxiliary cores, supplementary cores in a bigger system. It's not always used as a standalone thing. So Renode allows you to kind of model and simulate those complex scenarios and develop real-world products, and that's how they fit well together.
Can you talk about what kind of overview, what kind of visibility developers get? I think we can talk about Renode Dashboard.
Sure. So we created the Zephyr Dashboard, as we call it, to showcase hundreds of boards that Zephyr supports and how well that's covered by Renode. And the reason is that while developing tools, you often lose sight of how to present this to people, how to show the strengths of your framework, especially in combination with Zephyr. And we found the dashboard to be an excellent way to kind of show to people that you can actually simulate hundreds of different boards and run your software without actually having to buy anything. And it's been a great journey because it also allowed us to see a lot of patterns in the electronics world. Just like Zephyr is discovering patterns to make more efficient, its internal structure, the way it approaches driver subsystems, and so on. So this kind of symbiosis, let's call it, with Zephyr allows our simulation framework to also kind of develop in the direction of covering the abstractions that are created in the hardware world in a way that is kind of natural, natural both in the development sense. So of course we want to make our lives easier when we're developing Renode, but also just simpler for users, right? And the fact that Zephyr has this modular structure that allows us to reuse different models in Renode makes it just easier to kind of reuse stuff, to not redo code over and over and over again. And that translates to a better user experience.
How is Renode being used, for architectural, prototyping and hardware development, especially in the ML and security space?
We have quite a lot of users in different areas, and many of them will be developing products, as in use already created chips to build something physical. But more and more often, we have people approaching us at an earlier stage where they're actually just designing their solution, their chip. They might be building an ML-focused application. They might be actually very focused on security. One example of a security customer is Dover Microsystems, who are developing security IP to embed in different kinds of chips, and to find the right balance between security and speed. They need to do a lot of architecture prototyping and simulation in general. And they're using Renode. They love it because it's a very flexible and very fast iterating tool. Renode is also being used by Google to develop some security and machine learning focused solutions that we're working on together. And it's again being used because it's so flexible. It has so many user-facing features that allow you to just kind of prototype quickly. And this is useful both like in the product development context, but it's especially useful if you're trying to figure out what your chip's going to be, what it's going to do. And in security specifically, testing is extremely important. And since Renode focuses on testing, it has, the concept of virtual time, it has determinism, it has a lot of features focused on testing in particular, support for the robot framework, and so on and so on. A lot of security people use Renode because, if they want to test their device very thoroughly, there's this Precursor project, for example. Precursor is a safe and secure open source hardware communication device, which has multiple, parts in it, and it's kind of fairly complicated internally. And it's supposed to provide you this nice, secure isolation. You can communicate with people, and you're sure that whatever you message to them isn't going to be in any way compromised. And it takes a lot of engineering to develop this kind of security. And Renode is being used by the Precursor team to make sure that they're constantly improving their coverage in terms of testing, they're wiping out all the bugs and so on. We've just developed some pretty neat features inside Renode to help them build their product. And they have also been helping. They have been a great contributor themselves. So in total, these kind of collaborations are really great because security folks tend to be very kind of picky about how they test their things. And Renode is a tool that kind of takes testing to the next level. So it's a great fit.
Michael, thank you so much for taking time out today and talk about, of course, Antmicro, Zephyr, Renode, and how you're helping the ecosystem. Thanks for those insights. And I would love to have you back on the show. Thank you.
Thank you. It was my pleasure. Have a good evening.